For this video, we have this figure here, and we're going to prove that triangle ABC is similar to triangle EDC, and then we're going to find the same side length of CE. So the first thing we can do is write out what's given. So this is for A. So we know that there are two triangles, so triangle ABC and triangle CDE. But then we also know that angle B and angle D are congruent and are equal to 90 degrees. So angle B is congruent to angle D, which is equal to 90 degrees. And that is given. Number 2, we know that these angles are vertical angles, so that means they're going to be congruent. So angle ACB is congruent to angle ECD. This is by vertical angles. Now let's see if this angle, angle A and angle E, are congruent. So we can do the triangle sum theorem here. So we know that angle A plus angle B plus angle ACB is equal to 180 degrees. This is the triangle sum theorem. And then we can do some substitution. We know that angle A is congruent. We know that angle B is 90. And that's just substitution. We can also do triangle sum theorem over here. So angle E plus angle ECD plus angle D, I'm just going to put 90 degrees here. It's 180 degrees. And this is the triangle sum theorem. So then we can just set these equal to each other. So angle A plus 90 degrees plus angle ACB is equal to angle E plus angle ECD plus 90 degrees. And we know that angle ACB is equal to angle ECD. So I'll just substitute that. Oh, this here, this step number 6 is transitive property, since we just set them equal to each other. Plus angle ACB, because you can do substitution. So we can just subtract 90, subtract ACB, so it'll just be A equals E. And this is just simplifying. So if you subtract 90, since there's both on both sides, you can just subtract, and then you just have A and E left over. So now we know that all these angles are congruent. So by angle similarity, we know that ABC is similar to CDE. So therefore, triangle ABC is similar to triangle CDE by angle similarity, which states that angles where all three angles are two triangles with all three corresponding angles that are congruent, that means the triangles are similar. So there's that first part. Now let's do part B. So now we have to find the side length of CE. And here I'm just going to redraw out these triangles. So here we have A, B, C, where this is 9 and this is 12. And then I'm going to draw this one out. This is D, this is E, and this is C. And we have this point as 8. So we want to find this length here. So we also need to know this length. We need to know AC. So we can easily figure out AC by just doing Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. Pythagorean theorem. So I'm just shorten it out. And here a is going to be 9 squared. B is going to be 12 squared. And then we have c squared, so this is a substitution. And then we just do the math. Oop, that's 3. So 81 plus 144 equals c squared. So just simplifying. So this is 225 equals c squared. And then you just have to do this, square root. So c is equal to 15. So right here is 15. So now we know all of these angles, and we just need to figure out this angle here. So step 4, we can do something, we'll make ratios. So we'll put this as x for now. So x over 15 is going to be equal to 8 over 12. And then we just have to multiply 15 on both sides. So x equals 15 times 8 over 12. So x is equal to 120 over 12. So x is equal to 10. Therefore, since I said x is CE, CE is equal to 10 units. So you do the ratio, you multiply by 15, get simplified, so 15 times 8, which is 120. So this is all simplifying. 120 over 12 is 10. So we found out that this length right here is going to be 10 units.